Now I'd like for you to give this a shot. We're finding the volume of a solid. The base is the triangular region with vertices 0, 0, 1, 0, and 0, 1. Cross sections perpendicular to the y-axis are equilateral triangles. Give it a shot. Come back when you're done. Just in case you're challenged by the setup, here's my region, the point 1, 0, the point 0, 1, and the origin. And we're looking at that triangle, and we have these slices that are perpendicular to the y-axis, and then I drew this in perspective. And so we see that cross sections perpendicular to the y-axis are equilateral triangles. So here are my equilateral triangles. Okay, well, they're trying to be. Now, the area of one of these equilateral triangles is 1/2 base times height, or we can use that it's 1/2 AB times the sine of C, and that's really helpful because here we know the angle is 60 degrees and it's equilateral. So whatever my base width is, and let's talk about what that is, it's going to be x, isn't it? Just let that sink in, right? This is a point x comma y. And so if this is x, then this is x because it's equilateral. So we're looking at 1/2 x squared times the sine of 60 degrees, which is the square root of 3 over 2. Now it may look like we're all ready to go to our integral, but our slices are perpendicular to the y-axis. And so here we're using like a delta y. Thankfully, we have a pretty straightforward equation for this line. It's y equals 1 minus x. How do we know? Y-intercept is 0, 1, and this has a slope of -1. With all of this, now if you didn't finish before, I want you to go ahead and finish now. I'll wait a beat so you can pause it. After solving for x and replacing, we get that the volume is equal to the integral from 0 to 1. That's the interval on the y-axis for the region, times the quantity of 1 minus y squared dy. And the answer ultimately is the square root of 3 over 12.